Hello everyone. We all very much familiar with the equation y equals to a plus bx. What if I would transform this equation in the matrix form, that is y equals to capital X theta? What does this would imply? Well, if you have got a single data point xy, you can represent it in the following equation: y equals to a plus bx. There is no problem. But let's consider you have got three data points, like I have got 1, 2 and 3. These are my x points, x1, x2 and x3. I need to first find out what would be the y value of corresponding y value. Although I have just anticipated that these, let me consider that these are my y values. So subsequently, how the equation would look like. So am I going to write this equation 3 times the form of y1 equals to a plus bx1, y2 equals to a plus bx2? In this way will I continue, or do I have a better option? Of course we have a better option by virtue of NumPy, and that is in the form of matrix. So all these three equations we need to represent it in the matrix form. And how that matrix form would look like, this is what the matrix form would look like. So if we create this matrix whereby ultimately after we derive it, we'll get back to the same equation once again. Let me show you this. So if we consider the first column value to be 1 and subsequently the x features as x1, x2, x3 to be one matrix, and in fact this particular matrix has a special term that is called design matrix. So ultimately our target is to generate this matrix form y equals to x theta, so where capital letter X is basically our design matrix. Now the question is, how do we create the design matrix? Don't worry, we will take care about that one, and I will show you via Python how we created the design matrix. And then we also have our slope and intercept value in form of another matrix, and then we will perform the multiplication. So let's consider this multiplication by virtue of 1 into a plus x1 into b, similarly 1 into a plus x2 into b, 1 into a plus x3 into b. So finally we will get back to the same equation which we already have right over here, but this would be in the following format, right? So that means if I can generate this matrix form, then the work of the calculating the y value would be quite easy for us to do that, and that's what we are trying to achieve right over here. And that's how the equation will be transformed into the matrix form. So let me show you over here. Let's consider I have my x, following are my x values 1, 2 and 3. Initially this is in the form of a Python list. I need to transform into a NumPy array. So x is now a NumPy array, or you can call it as a vector, and I already have the following a and b value respectively, which I have just anticipated. Now what we have to do is that we have to create this design matrix x. So how do we create the design matrix? At first I have to generate this first column which is having the value 1, and for that reason we are giving a call to np.1 within bracket. The number of 1 will depend upon the number of size of my x, so that means number of 1 will be generated as a first column, and subsequently will pass the x value. So whatever data I have got for x, that will be right over here. And once we execute this, we are getting our design matrix, that is capital letter X, and that is one of the important parameter in context to my matrix multiplication form or matrix form. So we can I would like to show you the output of this particular program to see how the thing is actually looking like. And as I said over here, that this is how the thing would look like. Look at the output exactly look like that only. It is complete in the matrix form. So I have got the first column as 1, 1, 1, and subsequently the second column is my x value 1, 2 and 3 respectively. So my x, capital X, which is my design matrix, is very much created, and we already have my other matrix in the form of a and b. So that's what we are going to do right over here. So we are going to generate the theta. So initially these are simple variables, so I just want to transform them into such a format so that we can go for matrix multiplication, right? And this matrix multiplication require, what we know is that number of column of my first matrix should match with the number of rows of my second matrix, right? So let me print the output once again to show you that yes, the number of column of my first matrix does match with the number of rows of my second matrix. So with the help of NumPy.array, I have transformed these two separate variables into a dimension where we have got two elements. And remember, this is also in the form of a NumPy array. So basically it is in the form of a vector, right? Now Python provides us a very important operator that is called matrix multiplication, so in the form of theta. So this theta will allow me to perform matrix multiplication between these two matrices. One is the design matrix, which is in the form of capital letter X, and the other matrix is right over here. So we are giving a call to a special operator called theta, that is our matrix multiplication operator. So that means what we are trying to achieve over here is we are trying to add these multiply these two matrices. So 1 into 2 plus 1 into 3, is that what we are trying to do? The same goes for other rows as well, and finally we'll get the result. So let me print the output one more time. Let me clear the screen and let's run once again, and here it comes, right? So see how the output looks like. So 1 into 2 plus 1 into 3, so 2 plus 3 over here is 5, so 2 plus 3 is 5. So 1 into 2 plus 2 into 3, that is 6. So 6 plus 2 is going to be 8. 1 into 2 plus 3 into 3 is 9. So 9 plus 2 is going to be 11. And so we have got the corresponding result in the form of capital X theta. So after multiplying, we got these three values. These three values are whose values? These are the values of my y. So that means I have been able to derive my y value after I have performed the matrix form of multiplication, rather going through individual equation. So with the help of matrix form, we are able to derive the y value corresponding to the x, and now we can easily plot them in the graph, and that brings us to the execution of the following statement. So where we are giving a call to the PLT, which is the pyplot of the matplotlib, and eventually we are able to generate the scatter plot. So let me run the code now one more time, and to show you that final output is right over here, as you can see. So that means this is the value of y, right? So what is the value of x? The value of x is 1 and the value of y is 5. So x is 1 and the value of y is 5. That brings us to this particular point. Similarly, what about the next? The x value is 2, so we are right over here 2, and what is the corresponding y value? Is 8. So that brings us right over here. Similarly, we have got the x value as 3, so it's over here, and what is the corresponding y value? That is 11. That takes us right over here, and that's how we have been able to generate the corresponding y value, but not using the equation, rather using the matrix form of the equation, that is y equals to capital X theta. So from this particular program, I demonstrated how we can transform the linear model in the form of matrix form, and that too with the help of matrix multiplication operator. So this is what the content of this particular video, and here we have just worked with only single variable. But what about if my number of variable increases? Suppose I want to predict the price based on house price, where there will be multiple features like the area of the space, how many bedroom you have got, which location you have got. So there will be multiple x features. On basis of that, what would be the price? So that means in my next video I'm going to talk about how the matrix multiplication representation would be, not in corresponding to one variable, rather it would be in context to multiple variable. So let's wait for my next video. Until then, have a nice time. Bye bye.